Hello, hello, amigos. How is it going today? Hi. As you can see, we have a working, real camera. And it doesn't seem well placed. Who cares? I'll look at it that way. Oh, I know why. Give me a moment. That's because I have an offset that I haven't taken care of. The stream was awesome yesterday. I was so triggered. Holy! You know, there are some of these days where you have already not a good day. And then there's like that last thing, that one last thing that comes into your way and that just glocks you, okay? It just takes the glocks, empty the mag, you're dead on the ground. And I was entirely triggered, okay? There was no other way to put it. I haven't really looked at the settings on the cam, but I think that we're good with it. I think we're good. I don't think we're going to get any better than this. If there's a latency, just tell me. So. Turns out, the solution was to revert to an LTS kernel and reinstall the driver. Yeah. But it was too much for yesterday, okay? It was too much. I asked Gemini today, and thanks Google, it saved me, okay? True! Well, these things happen. I mean, what was I? I was like 2 weeks stream every day. We needed a day off, okay? We needed a day off. That's the truth. So, with that said, let's get into the fun part. Okay? Let's get into the fun part. So, I have not done anything. No other thinking. I really should, because every time that I think about it, I'm triggered. The design of my DB is just screwed. I need to fix that. I need to have a good think about it and fix it. So I guess that's where we are today. Yeah, that's where we are today. Oh, that's going to be a hard one. Anyway, let's get into it. Why didn't you start a new stream after the reboot? Or is it... Oh, my friend, I rebooted, I think, 3 times that stream. So it allowed it. But I just... you know, I reached that point. I already had a not so great day that day. So... I mean, that was a cherry on top, and I was like, nah, that's enough. That's enough. But, yeah, I don't know that I would have had that much patience to do anything, anything fun. We would have probably just gamed. But, I mean, there are those days. There are those days. Okay. That's a fair thing to say. That's a fair thing to say. But we're going to stream every day, like we're supposed to, and yeah. Even if the cam fails, okay, now I know what to do, and if it fails, next time I'll try to like look within myself to have the mental throughput to go through it. I just want to make sure that, oh man, I'm not even sharing my screen. Dear Lord, hi, I was doing things, me. I was doing some things over here. Oh, I think the chat is kind of screwed. I'll just... do this. Well, I don't want to cut this off. That should be on top. Yeah, that's what we want. Show my boy Dimitri. My loyal, loyal follower. You're pretty much there every stream. Holy. What programming languages do you use or no? I do not know any of them, and I use all of them that I need for my projects. No, I've had some experience with, well, some of them people won't consider them languages, but let's just go through it anyway. I've done some awk, I've done some bash, of course, Python, SQL, the MySQL variety, PHP, of course some HTML, some JavaScript. I've done a lot of things, but I'm not good at any of them, okay? There's a word for it. What is it? Is it, it's something and it ends by master of none. It is jack of all trade, master of none. That's the quote. That's the thing. But yeah, that's pretty much me. And I don't really have the mind to be a great dev and to understand these things without a lot of effort and putting a lot of my concentration in it. So, I mean, I roll with what I'm able to do. Good evening. How y'all doing? Doing great, Ghost. Way better than yesterday, let's put it that way. So. We have to find a solution to our problem. Because right now, if we go to the subject, okay? If we go to the subject, my problem is that my only thing that I have in my DB to store information about my tags is mtag. Mtag pretty much has nothing inside of it, right? So it has a type that would tell us if it's a struct, if it's a function, if it's something else. And after that, we would have some variables with specs inside of it. So we could like encode if it's a pointer, if it's a constant, if it's something else. So that's not enough. That doesn't work because let's just like, how would I set up a tag? For example, if I have a function that is supposed to return, let's say, an int. So I need to write somewhere that my function f is supposed to return an int. And let's say that I have two arguments. And those two arguments... Oh, God. And those two arguments would be like some weird type. Like, to my knowledge, we can feed a struct... Whoops. We can feed a struct into an argument, right? At least... That's possible in C, right? Is that possible, or I'm schizophrenic? But I think that we can pass structs into arguments. So my mtag system would not work. So it's kind of getting hard to know where I should go from here, right? Because, well, how do I encode this into SQL? Yes, you can pass structs into arguments. Thank Lord, I needed somebody to to pull me back from insanity. I wasn't there on Tuesday. I raided the milk thief in the Rust. What the fuck did that mean? Do you mean Rust the game? I have no idea what that meant. But yes. You are not obligated to be a slave to this stream. Not at all. But yes, so I need to find a way to encode all of this into a database. And from my understanding of how a database works, at least on the MySQL variety of relational DB, you can make links between two different tables. So this is a table, this is a table, this is a table, right? So here what you see in yellow, that's the link because we have a row, well, sorry, we have a column that contains TG ID, so the tag ID. And over here we have that same row that contains tag ID. So those two are able to be searched, right? So if I have the FID in this thing and I have an LNID, let's say, or I just have the FID, I would be able to list, well, it would have been better if I showed it instead of doing doing drawings, but you can like glue these two together as if they're one huge table. So let's just actually show this in action in one of the query. Maybe it's a little bit too complicated, but here we go. So here what we're essentially doing is we are joining mbridge and file name and version name. So by joining all of them together, we're able to search for a version name, and through the ID of that version name, it will be able to look into the bridge file and find what we need, and we are able to give it a nef name, and through the ID linked to this name, we're able to find what we want. So those are valid things to do inside of MySQL. Something that is not valid, at least in my current understanding, is an if, right? So let's say that you have, let's just call it spec, okay? Let's call it spec. Let's say that you have an int, so it contains numbers. I cannot really say if int is positive, look into this table. If int is negative, look into this one. That's not really something that I can do, or, well, I'm sure that technically you can, but it becomes slower when you do these type of tricks. Because SQL is not meant to do that. It's meant to just glue things together and go through it. So, good night and good luck with the development. Good night, my friend. It's all good. I love you. Nice seeing you today. And nice not having rage quit in front of you again. So, okay. Fuck you. Oh, okay. Sorry. Anyway, so we need to think about it without ifs. We need to think about it with gluing tables together. And if we don't do that, then we're screwed. So let's take a sip. So with that in mind, we need to find an optimized way to do this, because in its use, whenever we go on a page, it's a little bit like Bootlin, right? So let's just go on Bootlin and click anywhere, who cares? So we would have to like load all of these individual things automatically when we open up a page, and we would have to have access to the relations between other things. So it needs to be fast. I cannot really like have conditional for all of these things, at least not on the server side. So how do we design that? For now, my very basic idea, and by very basic idea is pretty much me just half rage quitting, is I would have a table. Let's draw this out using what we already have. So let's draw this out. Okay. Okay, so right now we have a table with, let's put it, yeah, that works. The nachos I ate are coming back. Holy. So, right now we have a table that links a specific version of a file with specific tags. That's great. We need that, right? Because when we want to like see all the tags within a file, we need to be able to say, I need this version and I need all the tags. Like this is, this is something that is basic that we need. So this, let's start drawing. This needs to be kept. This is good. the tag thingy is still somehow needed because we need to have somewhere to store all of these tags. It's just too complex. I think that integrating a lot of specs is probably not the best way to go with this. So I would most likely remove these specs, and we're going to replace them with something else. Now, the tag name, that's also good. That should stay. So my idea was to maybe make a more complex table that would be a table for structs, types, type defs, and they would be declared there, but without anything linked to their versions. So what I mean by that is that we would... Ooh, how could I say that? Everything else that we have, so the tag itself, for example, has a timestamp. So we know when it starts, when it ends. That's important because that's the data that we want to have, right? But we should probably have a middle system that itself just store, like let's say that we have a standard int. We should have a way to point to a table and tell us that this is an int, this is a standard type in C, and it has these attributes, right? That we could link to it. Same thing with a struct. We should be able to have something that says this is a struct with this name. It has these attribute, right? So we should be able to like have somewhere that points to this, so that points to the tag name. So we would have a tag name ID over here, and we would also have some unique ID here. The reason why it needs to be different than the tag name ID is because we can easily foresee, let's say that we have main inside of one file. Main is not a good example. Let's do a process, okay? We have a function called process, or a function called f. Let's make it even simple. A function called f, okay? If we have that function, well, it may be an int. Or maybe that's not a great idea. Who cares, okay? We have a struct called s. Let's make it simple. We have a struct called s. Maybe that struct has different characteristics depending on in which file it is declared. So this is why we need this unique ID for the specific thing, and we need to remove the timestamp out of it so that we can relegate the time stamping to only this mtag thingy. So here, when we would do a query, what we would do would be query the tag ID, and here we would have, well, let's say t-type would have been replaced by this universal ID. So we would have the information of what the thing is, and we would have the timestamp still inside of mtag, and we should... Because here we are only talking about types, we probably still need the tag name thing over here. It's just that the name of the struct or the name of the type should be different than yeah, those two might be different. Anyway, okay, I think we're cooking. I don't see how this fails. We could, yeah, and we could just, like, the querying of this could be fairly easy. Because this is all linked, right? So this gives us this gives us this, and at that point we have all the data. Okay. Alright. Surprised nobody's trashing me. I'm happy about it. I'm happy about it. That means that I'm either very boring or I'm cooking. Both works for me. So let's engineer this. So let's call this U. Oh my god, I'm going to make some naming scheme that is garbage. I need another name than tag. So it would be type ID. Yeah, I'll write it in full. Type ID. Okay. So let's make our table. Let's build this thing. Okay. So here, let's start with this M type ID. No, M type. That sounds fair. So the first thing we should do is type ID, which is an int, not null increment. That makes sense. We don't need a we don't need a timestamp. So we can delete that, and we can delete it over here too. We need a tag name ID, that's for sure. So this stays. I'm even going to put it forward because it is so important. Okay, so we have an ID. We have the tag name ID. So here, if we're talking about int, it would be written int in the TNID. Easy. Now, what more do we want from this? We should probably use this place to, how can I say that? Like, encrypt complex situations. I'm not sure how I would. Oh, that sounds cancerous, but maybe we could do this. Maybe we could chain them in series. So no, why would we chain them? That's idiotic. Okay, we probably need something inside of it that would give us the specification. So let's pull back tspec. Okay, we're gonna put tspec here. So tspec, let's put a full int, even if we probably don't need to. The idea of this will be to say if it's a const, say if it's a pointer, say if it's each of these things. So the idea here is that an int and a const int would be two different types inside of our system. So we would encode one as an int with some specific tspec, and we would encode the const int as another thing with a whole new tspec. So that would be the idea. Now, oh boy, oh boy. So this works for ints, right? So just having this would work for an int. This would work for char. This would work for standard things. Oh, let's delete this. And let's think about what we're adding next. Okay. So we already have everything that we need for an int with a bunch of characteristics attached to it. Now we need to think about how we are going to make structs work. That one's going to be hard. We're probably going to need to chain around a few more things. I think that's our issue here. So okay, let's draw again. Let's draw again and speak. It helps a bit. It helps a bit. So now we have our new table over here. We have something that points from the tag to this unique ID. So that already exists. If we have an int, that makes sense. Now, how do we make a struct work inside of this? Right? Because we need to have somewhere that we would store the information related to the struct. I'll need a new table, that's for sure. It's just that I want to reduce the searching around that we do. Because a big thing that I could do would be to link the TGID. So each unique tag would have inside of a separate table that we could call the struct table, right? It could have the components of this. But I feel that that would be slow as heck. Because we would have to... The reason why it's slow is because we would have to issue a call to search this struct table, even not knowing what the tag is, right? So if the tag is just function, we're searching struct for nothing. And that's my issue here. I don't want this to happen. So I would probably be better off putting the struct information at the end over here and have this like point to the table. So if it's a struct, we will have some information about the struct in general, about how it's used at that time at least. And then we could have something define it. And I'll need some kind of system over here to take care of that with more detail. Maybe that's the way to go. And I would just have to allow this column to have non-values, right? So if it's a none, it won't attempt to search. At least that's my understanding of... See you, my friend. It's all good. I'll be there tomorrow if you want. So, MySQL. Let's ask AI, okay? AI has been a savior today. So, Gemini, come the F back over here. It even helped me fix my my eating, okay? So, let's ask AI. I would like so much to have a voice thing. Just be able to talk to it. Wouldn't that be cool? I need to find a text-to-speech thing. I know that's boomer, but I'm a streamer, okay? Would be cool. So, okay. Okay, so let's think about this. So what we want... Well, let's say I first. Hi. I'm using MySQL. I was wondering if when a... How do we write it? I was wondering if when a column is set to none, if it still searches the other column on a inner join. Because if none is just treated as yet another value, we probably should, like... Maybe it's just an optimization that is impossible to do, but I'm just getting a bit triggered. Short answer is no. Oh, in MySQL and SQL in general, if a column that you are joining contains a null value, which imply none, the inner join will drop that row immediately. It will not successfully match with anything in the other table, not even another null. Ooh. Whoops, sorry, I made some insane sound. Now, let's put back the sound. Okay, that's pretty great. Now, my stress on this is that if I have a null, would it quit the search altogether? Right? Because I don't want to skip. I don't want to skip if they're not struck, right? I just want to have the information if there are a struct. So that's my issue here, right? Because we're going to, let's go here, right? In our drawing, we have I like drawings, okay? In our drawings, we have two tables over here and over here. And we have this pointing there. We have this pointing there. But we don't want a null value here, right? If we have a null, we just want not to search this. We still want the result of all of this. Well, this included. We still need the result for all of this. It's just that I don't want to go down that path in searching. So I guess we may need to, like, test it, or maybe it will tell us. If you want to keep the rows that have null values, it's reading in my mind! Even though as no department, you must use a left joint instead. Thank you, holy based! God! And most likely we can resolve all our problems that way, right? Like, let's not overthink the design, but let's just, like, think of the next step into where we're supposed to go, right? So we have big table here, we have small table here. So here it points there. Let's say it's a struct, it then goes here, right? That's all nice, right? But then we're going to go into, well, what if it is not a struct, but it is a function? So then maybe we can make a new table for arguments inside of a function. Or maybe we will be able to reuse, because arguments inside of a function looks a lot like a struct, right? So maybe we'll be able to reuse this. I think we're cooking. Okay. So maybe calling this a struct would be an overstep. Maybe we need to call this type group. Yeah. So, okay, so type group. I need to write this down somewhere. Why don't I know, okay? I'm in front of a computer, but when I do the print screen thing, okay, it freezes everything. I need to write that down, okay? We're cooking. Okay, cooking so bad. Holy. Okay. Okay. So. Okay, let's build this while in front of an image, okay? So. Let's just write this down before I forgot. So we were talking about type group. Okay. Oh man. My pen is dying out. Bitch. Work. Holy. Reload. All of my good pen are in the basement. That's unhinged. I'll need to bring it upstairs. And use it. Holy. We're doing good. Let's not forget this. Okay. So, don't die on me, you... Okay. Type. Group. It's dying on me. Group. Okay. I'll be able to read what we need inside of our type group, okay? We need... So we will need a unique type group ID. So let's call it type group ID. So that's the first thing that we need. The second thing we would need is the name inside of that group, right? Because if we have a function, for example, the argument itself will have a name. We're not only talking about the type, right? We will have int and the name of the arg. So we need to keep the name of the arg. Same thing for a struct. If we have a struct, inside of the struct, the elements will have names. So we need to have a tag name ID. So let's just write tnid. Okay, so we link tnid right in there. And then we would need to link back to this new type ID thingy, because we need to have the type of whatever the hell is inside of our struct or is inside of our argument. So type ID. My pen is dying, but I'll get through it. Okay, so this is type group. Okay, so we have, this is done. Okay, this is easy. Easy! That's a Z, okay? Can I do a Z? How do we do Z? Eh. No, that's a Z. I'm trying to look around if there's a Z, but nobody uses that freaking letter. Holy, I don't even remember how we do a Z. Okay, I'm traumatized. Let's forget that. Okay. So, now, we already started this one, but we have the unique type thingy. After that, we should have the name. So the tag name, so unique. So let's just call this UID. After that, we need the TNID. Oh man, I'm not even going to be able to reread this. The pen is dying out. Then we need the specs, so we need to know if it's a const or whatever. And then we would need to link to the type group ID. So type group ID. All right, this thing. And then we're done, right? So we're gonna be able to left join the shit out of it. Okay, let's design this. We're in. All right. Okay. Type ID, that's good. Tag name ID, that's good. The spec, that's good. The last thing we needed was a link to the new table that we're going to do. So before doing that, we actually need to create a table, because inside of MySQL, we need to make a relation between two tables, we need the table to exist. So, yeah, let's do this. Yes, so we are going to call it mtype group. Yep. And let's just copy this over. Whoop, this needed to be updated anyway. Okay. I know that the other one is not finished. Don't worry, I'll get to it. Okay. mtype group. So this should be type group ID. Int or increment, that makes sense. After that, we said that we needed a TNID for the name of the argument itself, right? So we have that. After that, we need a type ID. So we need to point to this. Ooh, we've got that circular thing going on. Oh, shoot. How do we cook this one up? Can we, like, post add a relation? Ooh. So maybe I'm just doing the relation the wrong way around. I'm just trying to think how it would even be possible. Wait. MySQL. Okay, the problem that I have right now, if you're following. So the problem that I have is that we have well, we have two tables, okay? We have two tables. And the two tables, like, point to each other. So which one do you create first? How do you fix this? I don't know. So MySQL to table having each other as foreign key. Circular foreign key. Oh man, that's the name. Okay, you are describing a circular foreign key relationship in MySQL, where table A has a foreign key of table B and table B has a foreign key of table A. This is possible, but must handle creation order and null default values carefully to avoid constraint violations. Holy, sounds complicated. Okay. Okay, so I need to... Man, that's unhinged. How will I do that? So the solution that they're giving us is to put one of the value to null, right? So if you have two tables that points to each other, let's just do the table, right? If we have two tables that points to each other, maybe add a new row, it will make more sense. So let's say that this is pointing to this, and this is pointing to this. Well, to be able to create the record here without pointing to something, we would need this to be null, for example. So then we would be able to take the value here and put it there, and then put the value there that would then come back and be put here. But how do I like design this? Like, this is most likely freaking easy in SQL to do, but I need to insert it inside of my system. That's the issue here. Like, on update, cascade. That's unhinged, no? Okay, so my solution here would be to handle the inserts and then add an update along with it automatically to these types of table. Oh. Oh man, that's going to be hard. But that's the most optimal way to go. Let me think about it a bit more. Okay, I think that maybe I'm thinking about it in the right way now. Just... okay. Shite. Circular won't work. Okay, it's too complicated. I need to find a way to streamline this. So... okay, let's think a bit more in SQL terms. Let's think a bit more in SQL. Okay, and let's make some lines over here. Why does it do this? Okay. Okay. Okay, let's draw and cook. So here we need to have something. Maybe we don't need the TNID at that point. Yeah, maybe we need to forget. Oh man, I think that we're cooking again. Okay. So what we probably need here is some kind of type, some kind of timestamp. That's all good. The TNID we probably don't even need. And what we should have is something that links to our type group thing. So here we would have the, type group ID, okay? Let's call it that way. So here we would have a new column, type group ID. So this would point to of course, the type group ID, and the way the type group... Wait, I need to think about this. No, I'm dumb. We still need the tag name over here. Or... no. Oh man, this is hard to conceptualize. Okay, let's think about this. So we have a struct. I'm sorry, I'm not speaking a lot, but it's hard to... So we have a struct S, okay? Let's call it that way. And struct S has under it an int and a char. Just to make it simple. So we need to encode this inside of our database. So what I'm saying here is that we should have type group ID. And type group ID would in that case point to... Oh, we're going to need that circular thing. Shite. Or maybe it's not circular because it's not... No, it needs to be circular. God damn. I need to uncircular this circular, okay? I don't know why I destroyed this. Okay, let's struct S, okay? Sorry. Let's write this again and try to make sense of it. So we have struct S. It has int. And it has a char. How do we store that into a DB so that it makes sense? So here let's just do something and think about it like later, okay? So here we would have a type group ID that would point to we need a bridge somewhere. We need a bridge. We are missing a bridge, and that's our issue. That's our whole issue here. We are making this way too complex because we don't bridge this. So, okay. Let's just create a new bridge ID. And man, this is hard. I'm trying to get away from that circular thing and I'm not able to. Let's see what I did in the past. And let's just try to think about it. Because in my head, the include already fixed this. But maybe it's just me that doesn't understand anything. Okay, so I have a bridge between include and FID. So that would be my bridge tag ID. Then we point to an include. We point to a tag. That makes sense. And then we point to the content of that include. Sorry, I hit you again. I'm just trying to think why that wouldn't work. It's because I would need to throw it back at the include again, because... Okay, I get my issue. Okay, it's circular for a reason, I'm not dumb, it's different than the include. The thing is that with includes, I never need to, like, take a value here and point back over here. But here, because types or structs can contain other structs. So I have the possibility of this happening. Maybe my issue here is that I put this under two different IDs, and that's why we have that loop-de-loop. That causes the issue. Because let's put a struct through this. And yeah, it wouldn't work. Okay, let's think about our struct again. It's hard. It's hard. Our brain is working big time. Maybe it's easy for some of y'all, not for me. Okay. Okay. So here, we need a way to store the name of the struct when it is declared. Yes. Yes, absolutely. Okay, so we need to store somewhere the name of the struct when it is declared. So here we would need the name somewhere in here. We would have an ID, and we don't need that TN ID. Okay, let's ignore that. And then let's say that we have the same way of structuring this than the include, right? So we use the same ID, but we add a rank so that we have like how they are ordered within our system. So if there are arguments, what's the first, what's the second, what's the third argument? And if there are structs, well, in order that we see them. Then we could have lower down something that points again. But it would need... Maybe if we left join this, so we don't necessarily need to have a m-include content. And over here we would have some type information. So if it's a struct, it will use the same ID. It will be able to detect whatever is over here and give us some clues about where to search for the IDs that would have already been put into the database. So here we would have a new IID if we use this example. Trying to see if it fails somewhere. I think it works. Oh man, I'm so sorry for not speaking a lot, but this is rotting my brain. The circular thing really killed me. And I don't know if this will even write. Okay. So our idea is that our tag table would point to a type ID. Type ID has two tables linked to it. It has a table number 1. Let's draw this on the screen and I'll write it down if it works. So, okay. So we have, that would be our type, table number 1. So let's call it type ID. Hey, I want my music. Come back here, Mozart. You gotta play. You gotta play. Okay. Let's type. So we would have the type ID. And here we would have the type ID. Whoop. Okay. So that makes sense to me. And then the second thing that we would need over here would be a name, because a struct has itself a name. So struct S, it has two components. It has int lol, and it would have char fun. Okay. So we have those two. So let's code that in. So here we would have type. So the type here, it would create an ID. We would need to store the name. And the name would be that, right? We would need to store the specs. And that would be for that. So we have the name, we have this, we have what this is. So if this is like a constant, we would know. Then we split off. It's probably not bright to store if it's a constant there. I'm not sure about spec being here. But anyway, let's think one step further. So here we would still have that rank, that works. We would have that type at the top. We would need to have a name, and the name would be for here, right? We would need to store this. So here in reality, this type, so let's say that we have type ID 1, we would have two things with the value type ID 1 over here. So over here. But one would be rank 0, the other one would be rank 1, right? So this would be 0, this would be 1. So now this would work. We would store the name here, and then we would be able to store a new type ID over here. To be able to loop back to this. But in this example, this is not a circular this is not a circular table because we are using the same ID. Yes, yes, that works. Now my only issue with this, is that we probably should not store the spec in here. Right, because the fact that the struct is a const, that should probably be along with the tag. Right, because we are assuming here that we have a tag somewhere in here, and that tag would point saying, hey, I have this type. And it would even name it another way, right? Because when we create a struct, we then use that struct with a new name, right? So I can, yeah, we all know that, right? So I declare the struct S, and then I use S and give it a new name, so S variables, and then I would use it. Okay, so the tag itself, the tag already has a name, but we need to keep the name inside of the tag. So this needs to keep its name. That's for sure. This we need something in there to store what it is, because if it's an int, we would like to know that it is like a simple type and that it's not a struct or that it's not a type def, and we would like to see the difference between a type def and a struct, right? So we need some kind of type indicator in here. Ah, shit. And it would now be at the tag level that we would store the specs. So if it is a pointer, if it is a constant, if the pointer itself is a constant, or if it is not. So that's something that we're going to find a way to store inside of the tag. While here, we would need the spec too, right? Because if inside of a struct, we have a pointer, we need to be able to say that it is a pointer. So we need the specs in there too. When I say in there, I say inside of the second part of our type ID. Holy. I hate the fact that my pencil is not penning correctly. Okay, let's just write a couple of things. Tag contains specs. Oh my god, I don't know how to read. After that, we would have a type table that contains type ID. It contains the name. contains summary type info. I hope you can hear me. Okay, summary type info. And that's it for this one. So now we move on to this one. This would contain, so type content. Oh my lord. Type content. It would contain rank. Well, type ID first. Type ID. Type. Sorry, rank afterward. Rank. After that, it would be the name. I'm writing it down so we never lose it, okay? Then we would need a new type ID. And the specs. Let me just write down the example again. So if I have struct s, let's make a curly bracket. Okay. So this goes over there. Okay. This over there. All right, I think we got it. I made a drawing. Okay. Hi, I'm becoming insane. We are doing DB design to try to resolve the problems of the world. All right, let's let's implement this shit. All right. Okay, my thing is going to bug out because it's going to break everything else. So here it shouldn't be type group, it should be type content. So let's call this type content. Let's just start with our type thing. Okay, so inside of our type table, the first thing we need is a type ID. We've got our type ID. The second thing we need is the name of whatever the hell we're talking about. So tag name ID, that's good. After that, we need a summary info of what it is. So I was about to call it tspec, but let's make it different. Let's call it tinfo because it is less extensive. And we're also going to put a tiny int just so it's very freaking clear that we're not supposed to put everything in there. Okay, so that's the first thing. Whoop, not looking at the right place. Okay, so now let's delete this. We don't need this anymore for type. Okay, what's the primary key. The primary key is type ID. TNID should be linked, that's for sure. Alright, so we have 1, 2, 3. We have 3 columns. So let's put 3 zeros as the default. Right, that makes absolute sense. Alright. So now, M-type content. So let's put again type ID as the big guy. We probably should not do the auto increment thing because it is not an auto increment thing. It follows whatever type needs. Yes, okay, sorry, I was bugging out. We're all good, we're all good. Yes. Alright. Let's resume. Okay, type ID. Now we need a rank. Let's just steal the rank that we have from include content because it works. Okay, so let's steal that. We're gonna need another name, right? Yeah. Okay, rank. After that, we have the name. Tag name ID, that's great. After that, we need a new type ID. So let's name it a little bit differently. So type ID. Let's call it inner type ID. Yeah, inner type ID. It needs to be the same value as the other type ID. Type ID, auto not null. Are they unsigned? They're not unsigned. I'm not insane. Okay. And then we need specs. And could that be null? No, it couldn't. No, if we're creating something, it's because it needs to be there. Okay, that makes sense. All good. Okay. Now the key is type ID. Conjugated with rank. I'm happy with that, but I also need the type ID over here. That's for the foreign key. So here we are creating the foreign key that goes from there. So we are linking the type ID to M-type. Okay, that looks good. Yep. Okay, so we have recreated our structure here. Let's just make sure that it makes sense. Type ID, all of this is linked. All right. Rank, TNID. TNID should be linked to tag name. True. And then inner. Okay, inner needs to be done too, right? Because the inner type ID still needs to be linked to type ID. Oh shoot, I screwed something here. I think that's how I do it. Let me just make sure that I'm not doing something dumb. Where do we have the version things? Okay, yes. Yes, that's how we do it. Okay, okay. Now, last thing that I need to do is to set the default values. Should I even have some default values? Let's put some zeros. 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5. Alright. Okay, default values. Good. Let's just check if the include has some thing up their sleeves that we should be looking at. False. Oh, okay. So for my second include, I haven't included any default. Alright, I'll follow. Okay, I think we're cooking. So that's the include that we had in the past. Oh, sorry. That's the include. And we are setting the first one to false. I'll just follow this, even though I'm not sure what it does, because I don't remember. But we're just going to think that Maple was smarter whenever he was doing this. Okay, so this should fix... This should fix everything. Yes, okay. Okay. This is unhinged. I think I'll just run it so that it creates the DB. Oh. I need to declare them. Sorry, initialize them. I have the initializing thing here. M-type. Content. Then I should be able to do the create table. I'll answer. I just want to finish this. Did you just hop on, or were you there for my schizophrenic breakdown? Type content. Yeah, that works. Yeah, I don't know what you're talking about. Your color are good. Alright, that should work. Key column T. And we're talking about who? M type. I miswrote somewhere, I guess. No, just aren't. Okay. So to fill you in, just the TLDR, my dear friend. So we did some DB schizophrenia over there. We ended up, I know that it's like not seeable, but we did some, we wrote it down. But yeah, we went into like some design. I did a couple of design. I don't really like writing the SQL myself, so I prefer like doing drawings and stuff and doing like, oh, okay, we're going to add this in here and we're going to put a type thingy in there. So we did that for an hour and a half. And now we're just inserting it inside of the system that I made to handle the DB. So I now know, because of the likable people, that there is such a thing as SQL alchemy and all of these things. But yeah, I already baked a whole system made to handle the DB for me automatically, to create it and to do all the relations and thing. So I'm just inserting it inside of the system that I've made. But the design of it was paper and drawings. So yeah, I'm not designing it. I'm not designing it just now because I've got it written down, right? So right now I've got some errors, but they're just me that doesn't know how to type. So I'll find this. Shouldn't be that hard. Probably in here because I removed a whole bunch of shit. Yeah, it says column T doesn't exist. But there's no T. There's no T! Where's the T? Okay. No, I screwed around with the parentheses. I know I screwed something up. I did it a little bit earlier. It's my bad. Okay, fair enough. Thanks for clarifying. Yeah, I'm not saying that this is optimal, but behind this is all the system that handles it to emulate a DB while I'm running the multi-core processing thing, so that I don't have to do DB calls while processing, which is 100 times faster than doing SQL calls. So that's the thesis for the need of this. I don't know if SQL Alchemy can actually like emulate the DB on your system, but I know that it can simplify this shit. So I know. Okay, but now my problem is that this is undebuggable. Okay, mtype create table. The problem is in ntype. Okay, so ntype, type ID makes sense. TNID makes sense. tinfo makes sense. Type ID, this is here in the prior. We have the end of this parentheses. This makes sense. The second value is for the primary key. Yes, this still makes sense. The second thing... Ooh, I thought that... The second thing was the default, but here bridge include is making me think, nah. How did I set this up? Or maybe it's just a bridge include that is screwed somehow and... Oh, I skipped it. Okay. First thing, let's zoom in. Whoops, not that. Okay. So the first thing is the table name. Second thing is the columns. Third thing is the primary keys. Oh, maybe I screwed this up. Maybe that's my issue. Okay. Name. Tables. Primary key. Sounds good. And then it's the foreign key, which is the only one is TNID. So that's good. Then we have the double parentheses because it can be more than one. Then it's the default. There's 3 values, so 1, 2, 3. Yes. 3 zeros. Makes sense. Tag name ID has the value of 0 by default, so that makes sense again. After that I put false. Maybe it's just dumb for me to do it, and I don't need to. I'm sure I don't need to, but... No duplicate. Yeah. I don't need that, but I'm going to need get list for the second one. Okay. Oh no. That's the one that I'm... no, sorry. Okay. So false, I don't need. And I don't need get list for this one. Okay. Those other things are just extra functions that I've coding in. So false, let's remove that to remove the chances of errors. Here though, we are going to need to do false and to do true because we need to be able to get more than one from this thing. Okay. Was the duplicate P in duplicate on purpose or just a funny coincidence? Where? Duplicate is with 1P? Oh no. Oh, that's good. Nice catch. I screwed it up through the whole program. Oh, that's great. I love it. Oh, and not only once. God. Okay, let's fix this. All right. Oh. What a sad time to ask what's going on, because I'm gonna need to go. Oh. And I'm a little bit triggered that it still doesn't run, but I'll find the error, like, right away, probably. Once I look on it with a brand new eye. But yeah, I've got to go to the pharmacy. And then I gotta sleep. But yeah, just to give you the detail on KernelInfo. KernelInfo is just a project that I do where we parse the kernel, we shove it all into a MySQL database, and we are going to make a cool website with it. So this is why I'm frantically trying to fit these things. Oh, I'm so triggered. I don't want to go on this. Oh man, where's the mistake? It's probably not even in here, and it's in some other code that I, like, screwed up by mistake. Oh no. Where is the table setup thing? Create table? That's where it's shitting to bed, right? Create table. 428. Okay, so it's here that we're dying. So there's probably like a T somewhere in there that I just threw on by mistake, like I always do. Good night, friend. Good night. Shoot, I'm addicted. I'm not going to search for, like, T, okay? I'm not, I am. T! We're finding T. Find all the T's. Is this something that is findable? Like, do I have, like, a left T somewhere? Searching for this is a war crime. Key column T doesn't exist in table. My code is just fucked. I'm sure it is. I'm sure, like, this code, this is viral AIDS. It just doesn't work. And this is my issue. Okay, no. Okay, I'll check this tomorrow. Okay, I gotta go. I got shit to do. I love you all. I'm going to be there tomorrow. We're debugging this. And we're gonna be awesome, all right? We're gonna be awesome. This is the thesis for tomorrow. Love you all. See you tomorrow.